Okay guys, in this video we're going to be looking at how we could actually write the equation of a parabola in standard form, or that is y equals ax squared plus bx plus c form, given that it passes through a set of points. And so, of course, if I wanted to write the equation of any parabola, we could certainly do this if we knew the values of a, b, and c, but let's say I know 3 or more points. Well, what we're really being given are values of x and y that we can go substitute into the equation for all of our x's and all of our y values here. And so, since, oops, sorry, no x there. Since I would say y and x are known, the only things I would know are a, b, and c, and we certainly could come up with 3 separate equations if I knew at least 3 points on my graph. And so that's precisely what we want to carry out here. We want to say, well, if I know that these are 3 points that are on my graph, then let's go plug them in, come up with 3 separate equations where we don't know a, we don't know b, we don't know c, but that doesn't mean we can't solve a system and figure them out. So let's go ahead and start with this. With respect to our system, we're going to say, starting with our first point here, 0, 3. I'm going to go ahead and just kind of separate these distinctly here. We're saying that our y value in our equation here for y equals ax squared plus bx plus c, our y value would be 3 if our x value equals 0. So we have a times 0 squared plus b times 0 plus c here. What we find out pretty quickly is that this first equation comes out to be c equals 3. And so what I'm going to do is I'm going to list that over here. We say c equals 3 is our first equation in our system. Now, going for our second equation, we're going to use the point 1 comma 4. So 1 comma 4, when we plug this in, we would say our y value in our equation would be 4, but only if our x value is 1. So we have ax squared, where our x value is 1, plus b times x, where we have a 1, plus c. What we end up getting here, and we do our exponents first here, is we get 4 equals 1a plus 1b plus 1c. And so I'm going to write this actually as a plus b plus c, and I'm going to put my constant on the right side. But here's the second equation in our system. To get the third equation, we'll go ahead and plug in the values for our third point. So we would say, well, I know my y value is 3 when my x value is 2. So I have a times 2 squared plus b times 2 plus c, where in this case, excuse me, we get 3 equals, well, this would be 2 squared, that'd be 4, so we get 4a plus 2b plus c. We would say this is the third equation in our system, so we have 4a plus 2b plus c, and this is equal to 3 in this case. And so something really neat about this system is that we actually already know the value of c here, which would mean that we could actually go ahead and plug that into either of these two equations here, a plus b plus c equals 4, or we could plug it into 4a plus 2b plus c, which is 3, equals 3. The reason why this would be neat is because if we were to now, say, subtract 3 from both sides here, we'd get a new equation, a plus b equals 1. And if we were to subtract this 3 from both sides of this equation, we would have 4a plus 2b equals 0. And we could just go ahead and solve this using elimination or substitution. In this case, if we are to use elimination, I suppose we could take everything up here times a negative 4, and we'd end up with negative 4a minus 4b equals negative 4. And our second equation would be 4a plus 2b equals 0. Well, then I suppose we could say that my a's cancel out, and I get left with negative 2b equaling a negative 4, which means the b value we're going to get here is 2. And if our b value is 2, then we know that a plus b equals 1. Well, then we have a plus 2 equals 1, which means a equals negative 1 in this particular case. And so we would say that if those are the case, then we could plug this back into the original equation up here. A plus b plus c equals 4. We get a plus b plus c equals 4. We would really get a, which, by the way, we've already discovered is negative 1, plus our b value, 2, plus c equals 4. Well, combining these terms here, we get a 1 plus c equals 4. And so our c value has to equal 3. So now that we know a, b, and c, I mean, typically we write our solutions like this. We'd say a in this case, we found out is negative 1. B in this case is 2. So we have these two right here. And then our c value is 3. We would want to go back now and write the equation of this parabola. So we have y equals ax squared plus bx plus c. And if it went through those 3 points, then we really get y equals negative 1x squared plus b, which is 2x in this case, and then plus c, which is equal to 3. So one thing I actually did want to do on this was go graph this equation here. And so if I were to go to y equals and type in negative x to the second power plus 2x's plus 3, the idea is that we would have this parabola here that goes through 3 points for us here. We have 0, 3, so it's kind of hard to see. Let me bring this up over here. If I go to my table first things first, you'll say 0, 3, 1, 4, and 2, 3. And so these 3 points right here are definitely on my table. And in terms of my graph, we could trace to 0. We say 0, 3. If I plug in 1 for x and trace there, I get 1, 4. And if I plug in 2 for x, I should get a value of 3. And so it certainly does pass through this. So I have to mention something here. You're going to see more problems like this, but one of the x values we plugged in was 0. In the case where one of your x values is not 0, what that means is you're going to get 3 equations, and all 3 of them are going to have all 3 variables. And so in that case, what you'd want to do is solve using Gaussian elimination and get it into row echelon form. So just very quickly here, I want to show you how I might try that even with this equation that doesn't have any a's or b's here. So first things first, I would rearrange my system so that I have a leading 1 in the top left corner here. And so that means that I would put my second equation as my first equation. I'm going to put 4a plus 2b plus c equals 3 underneath it. And then I'm going to leave c equals 3 right down here at the bottom, as a matter of fact. So with this, remember that we're going to use this leading 1 to get rid of anything underneath it. And the way we're going to do that is we're going to multiply it by the opposite of the thing we're trying to get rid of, and then adding it to that thing we're trying to get rid of. So in this case, we're going to take row 1, we're going to take it times a -4. -4 times row 1, we're going to add that on to row 2. So what that's going to do is it's going to produce a new system. Now equation 1 stays the same. Equation 2 though, let's get our calculators handy here. We know that if I were to take, okay, -4 times 1 and add it to 4 here, this would now become 0 a's. But if I take -4 times 1 here, we would get -4 times 1, and I add that to the second row, which has a 2 here for our b values, I get -2, so I get -2b. Now we're going to take -4 times this 1 and add that to this 1 here. We get -4 plus 1, but just to show you, you can do it formally with -4 times 1 plus 1. We get -3, so we get -3c, and then we'll take -4 times 4 and add that to our 3 in our second equation. So -4 times 4 plus 3, we get -13 here. And so our last equation, we had this c equals 3. Well, now what we would want to do is we would want to get a leading 1 here. And the way we do this is we could always multiply, if switching rows doesn't work anywhere, we could multiply by the reciprocal of what the leading coefficient currently is. So if we were to take -1/2, the reciprocal of -2, and multiply that by row 2, we get a new system here. We get a plus b plus c equals 4. This would now become positive b, because when we take a -2 times a -1/2, anything times its reciprocal is 1. Now, -3 times -1/2, keep in mind you multiply fractions straight across. So I get positive 3 over 2. So we would get 3/2 c. And over here I would get -13 times -1 over 2 would be a positive, and we're going to get 13 over 2. So now with our last excuse me, equation being c equals 3, pardon me, we would now be in row echelon form. That is, we'd have this stair-step pattern with leading 1s in all 3 rows. So at this point we could say, well, then I know that c equals 3. And plugging this back into the second equation here, I would have had b plus 3/2. Just to show you that these fractions aren't that bad here, we plug in 3 for our c. We get 13/2. Well, then I would have 3 over 1 times 3 over 2, we get b plus 9/2 equals 13/2. And by subtracting 9/2 from both sides, I get 4/2, or in other words, I get 2. And so now by knowing that c is 3 and b is 2, we could certainly did what we did initially, which was plug it back into the initial equation to go solve for a, which we already have determined was -1. So the idea here being you can find a, b, and c just by plugging in 3 pairs of x's and y's and getting 3 different equations, and then either using Gaussian elimination or some other type of method to find a, b, and c so that you can write the equation. So don't forget to write the equation. Cheers.